Now I'm going to tell about what is sharpening filter, image restoration and image enhancement, and the definition for sharpening filter. It should be used to highlight the details of an image and the frequency in the image that the component should completely having the information put in the form of edges and boundaries, and this image should be used to enhance the image. And in this the algorithms should be used to separate the objects from their outlines, and this it is also used to sharpen the edges and boundaries of the whole image, and it is also called as edge enhancement or edge crisping algorithm. And in this sharpening it involves four most important filters: gradient filter, Laplace filter, high boost filter and sharp masking filters. Coming to there is a difference between blurring and sharpening. First of all, blurring it should be used to blur the effects, and sharpening in this these both are like similarly same, but there is a difference in between this blurring. In this blurring, it is done in spatial domain by the pixels. The pixels should be averaging their neighbors and it is the progress of integration. And what is sharpening? The inverse process of this blurring is sharpening, but it should be in interior, and it is used to find the difference by the neighboring, and it should be done by the spatial differentiation. And in this sharpening filters, the most important one operator is used. That name was derivative operator. It should be used to calculate the gradient of the image intensity at each point of the image, and it should increase the form of light to dark and the rate of change that should be in the direction at each point. It is most important operator. This is the foundation of the sharpening filter. Foundation of the sharpening filter should be written for both one dimension and two dimensions. One dimension, the first order derivative is del f divided by del x equal to f of x plus 1 minus f of x. F of x is the difference and the f of x plus 1 is the difference between them. Similarly, it should be written in the second order derivative, del square f divided by del x square equal to f of x plus 1 plus f of x minus 1 minus 2 f of x. And this is the two dimension. This is the formula for the foundation of the sharpening filter. Now we are going to see the sharpening filter should be sharpened by using the one of the filter. That name was Laplace filter. Laplace filter is an 2D isotropic measure of an second spatial derivative of an image, and it should be used to remove the blurring from the image, and it should be used to highlight the edges. In this, the image should be enhanced. Sum of left of the sharpening will always be 0, otherwise it should be minus 1. And for example, it is the given matrix. In this, the image should be represented as a matrix formation. It should be written at a matrix. In this, it is an enhanced image. The edges of the image should be 0, or otherwise it should be a minus 1, and the center element should be incremented. We can multiply the original and the enhanced image. In this, we cannot use the matrix multiplication. We just use the element multiplication. One should be multiplied with this minus 1. Likewise, 2 should be multiplied with minus 1. That should be, and finally the answer should be 9. This is the example for sharpening filter using Photoshop application. Thank you.